Today in this video about trigonometry, we're going to be learning how to find values of angles for which sine and cosine theta or tangent theta even are the same. Now, I've gone through this in graphical form in my video about the graphs of the sine, cosine, and tangent functions. But in this video, I'm going to quickly go over the intuition of how we would find these in the unit circle. So, for example, you have your unit circle here, and you want to solve the problem that sine theta is equal to sum a. For the interval, 0 can be less than or equal to theta can be less than or equal to 360. And basically, what you do for something like this, your calculator would give you the value here, where you have this triangle, and this is how a would be. And then what you should do is you should just draw a line here, and you can realize that there's another triangle over here, which is theta degrees from the 180 line here. It's theta degrees away, just like this is theta degrees away from 0. And so if this is angle theta, and then 1/2 turn is 180 degrees, then this must be a gap of angle theta between our angle theta 2 and therefore the other angle for which sine theta is a must be 180 minus theta. Now, how does this work? Well, this is because when we draw a horizontal line here, this is the line of y equals a, or y equals sine theta. And because every point on the unit circle has the y coordinate that is equal to sine theta, the other intersecting point on the unit circle for which y is equal to sine theta, the other intersecting point on this unit circle must be with another angle of theta for which sine theta equals a is true, because the y coordinate is sine theta and sine theta is a, and it's intersecting with y is a, so therefore sine theta is equal to a here. And then this intuition, if you think about how the x coordinate of any point on the unit circle is cosine of theta for the unit circle, you can realize as well that for any sort of value of cosine theta, say you have the unit circle here, and you have your triangle here, you can draw the vertical line here, which is the line x is equal to cosine theta, because at the points where it intersects with the unit circle, the x coordinate will be cosine theta. And so the triangle down here will be also valid for the same value of cosine theta, and you can take whatever angle this is here. And just to give you this in algebraic form, say this is an angle theta, and we know that means this gap here must be also theta degrees, and therefore theta 2 plus theta is equal to 360, or the other angle is 360 minus theta. And this is the algebraic form of this intuition here. You can use this for any kind of angle anytime you want, because you'll know that something is theta degrees away from a certain important point, like 360 or 720 or 180 degrees, because oftentimes things will be theta degrees away from these key values when you're looking for values of theta with the same cosine and sine. And finally, as we discussed earlier, tangent is the gradient of the line within the unit circle, because if the change in y from 0 to, because like we know that tan is sine over cos, basically. So tan theta is sine theta over cos theta. And so the change in y from 0 to something sine theta divided by the change in x from 0 to cos theta is just going to be sine theta over cos theta. Like the gradient is just going to be sine theta over cos theta, and so this is going to be tan theta. So obviously on the unit circle, you're looking for something which has the same gradient. So say you have your unit circle here, and you have your angle theta here, and you're looking for something with the same gradient. So that would be whatever line goes down here, meaning that here is your theta 2. And because you've just clearly added half a turn of the unit circle onto your original angle, you can say that for any tan theta is equal to tan theta 2, theta 2 must be theta plus or minus 180. Because you can also go the other way as well, in fact. And then, yeah, basically there's a gap of 180 degrees in between every value of tan theta, in between every value of theta for which tan theta is the same. And again, looking at the graph helps, but I'm just trying to go over the unit circle intuition because like there's a line here and all these gaps are the same. But anyway, the key point to learn here is that you can find that tan theta is tan theta 2 when something is like half a turn away because of the way it'll look in the unit circle. The gradient will be the same and the lines will look as if they are part of the same line. Alright, so in summary, to get angles of theta for which sine theta is the same, you draw the horizontal line there because the horizontal line indicates the y level of the coordinate and the y level is sine theta. For cosine theta being the same, you draw the vertical line for an angle of theta and you find the other point on the unit circle for which that vertical line will intersect it because the vertical line shows the x level and the x level is equal to cosine of theta. And finally, the tangent of theta, you will draw the line on the opposite direction in the circle because they will appear to be part of the same line because they both intersect 0, 0 and they have the same gradient. Alright, thanks for watching.